for the next part of the solution. So that is the graph for azeotropic mixture. Last class I told the azeotropic mixtures are two types. One is your minimum boiling point azeotropic mixture, another is your maximum boiling point azeotropic mixture. So let's say here, first of all I am going for the minimum boiling point azeotropic mixture. The minimum boiling point azeotropic mixture is possible for the non-ideal solution showing positive deviation. Non-ideal solution showing positive deviation. For example, let's say I want to take a positive deviation solution consists of ethanol and water, and it form a ethanolic solution. So it form ethanolic solution. The boiling point of ethanol is 351 Kelvin, that is in an exact of 351.3 Kelvin, sorry, this is 351.3 Kelvin, whereas the water boiling point is 373 Kelvin under the atmospheric pressure of 1 atm. We want to form a azeotropic mixture by taking 96 gram ethanol with 4 gram water. Then the solution mass you will get is your 100 gram. And by mixing this 96 gram in 100 gram solution of ethanol, that means I can say this is the 96% and this is the 4% by mass. And the composition ratio in the solution is 96:4. And under that condition, if I want to get the boiling point of the solution, the boiling point of solution will become 351.1 Kelvin. And this boiling point is less than the boiling point of the ethanol as well as the water. And for that reason, the solution is called minimum boiling point azeotropic mixture. And in this minimum boiling point azeotropic mixture, if I want to plot a curve by taking percentage in x-axis and temperature in y-axis. Here I will take the ethanol here, C2H5OH, and let's say it is 100% present here. And here I will take the water, and let's say here it is 100% present. So this is the pure ethanol and this is the pure water. The boiling point of pure ethanol, already you have written, this is 351.3 Kelvin. This is the point of boiling point of ethanol is 351.3 Kelvin. And the boiling point of water at under 1 atm pressure, that is 373 Kelvin. And we are taking a mixture of ethanol and water with a 96:4 by mass ratio. So let's say this is the point at which you are getting the 96% ethanol. So this is the point we are getting the 96% ethanol. So if the 96% ethanol is there, automatic 4% water is there. And what is the boiling point of it? This boiling point is 351.1 Kelvin. So this boiling point is 351.1 Kelvin. Let's say I will take the boiling point of this is 351. Let's say this is the point of 351.1 Kelvin. So this is the, let's say 351.1 Kelvin. Now if the solution, let's think the solution is ideal. If I will think the solution is ideal, then its graph should be a straight line, because for the ideal solution delta V is 0. So if the solution, by assuming ideal, then it should have the graph like this. But our solution is not ideal. Our solution is non-ideal, and it shows positive deviation. Positive deviation, it indicates that the vapor pressure will be more. So the vapor pressure curve should be above the curve of ideal solution, because its vapor pressure is more. So this is the curve for the vapor pressure. And what should be its boiling point? As we know, the vapor pressure is more, means boiling point will be less. So its boiling point curve will be just below the ideal solution curve. So this is the non-ideal solution of positive deviation form azeotropic mixture, and it is your minimum boiling point azeotropic mixture, and this temperature is your 351.1 Kelvin. So this is the graph I told for the minimum boiling point. Now we'll go for the maximum boiling point azeotropic mixture. So let's say I will go for the next graph for the maximum boiling point azeotropic mixture. So what is maximum boiling point azeotropic mixture? This mixture is possible by a negative deviation non-ideal solution. Negative deviation non-ideal solution. I will take an example of it. We are taking nitric acid, HNO3, and we will add water and we will get the nitric acid solution. So here we will get the nitric acid solution. I will take 68 gram nitric acid and I will take the 32 gram water. Then we will get the 100 gram solution. 68 gram nitric acid in 100 gram solution means it is 68% and this is 32% my mass. The boiling point of pure nitric acid is 359 Kelvin, whereas the boiling point of water is 373 Kelvin under 180 pressure. And when I will mix 68 gram with 32 gram, then the solution what will get, its boiling point will be 393.5 Kelvin. And its boiling point is more than the individual component boiling point. And for that reason, this shows the maximum boiling point azeotropic mixture. So if I want to plot the curve for the maximum boiling point azeotropic mixture, in the same way what I did for the minimum boiling point azeotropic mixture. So let's say here I will write this is the percentage and this is your temperature axis. Here I have written the HNO3, concentrate HNO3 100% pure, and here I will take the water 100%, that is pure. The boiling point of nitric acid is 359 Kelvin. Let's say this is the 359 Kelvin, and the boiling point of water is 373 Kelvin. And we are mixing in the ratio of 68:32 by mass. Let's say this is the point. Here the nitric acid is 68%, so the water will be 32%. And the boiling point of this solution is 393.5 Kelvin. So this is the point. Let's say here the temperature is, let's say, 393.5 Kelvin. So this is the solution we are preparing. Again, assume that it is ideal. If I will assume it is ideal, that indicates the graph should be straight line. But our solution is not ideal, and it shows maximum boiling point azeotropic mixture, and it is a negative deviation. Negative deviation means its vapor pressure is less. As its vapor pressure is less, so that indicates that its vapor pressure curve should be lying below the ideal curve. And as it is maximum boiling point, that indicates the solute-solvent interaction is more. That indicates that its temperature curve should be lying above the ideal curve. So this is the temperature curve and this is the vapor pressure curve. This is for the non-ideal solution showing negative deviation of maximum boiling. Non-ideal solution showing negative deviation with maximum boiling point azeotropic mixture. So here the temperature you will get is 393.5 Kelvin. So this is one of the example for the maximum boiling point azeotropic mixture. On the next class I will go for the Van factor.